Welcome everyone. In this video we are going to study about the periodic table in which different elements have been arranged. And we know that element is the simplest substance that cannot be broken down further during a chemical reaction. Since time immemorial till the Middle Age, just a few elements were known to man, and these were carbon, sulfur, iron, copper, mercury, silver and gold. First new element discovered by man which is on record is phosphorus. It was discovered in 1669 and it motivated scientists to discover more and more elements. So the number of elements increased with time. By 2011, 118 elements were discovered, and today, that is 2020, still there are 118 known elements. When the elements were lesser in number, there was not a big problem to study them. But as the number increased, it became more and more difficult to study and remember the properties of all the elements and all the compounds formed by those elements. So scientists try to systematize the study of the properties by classifying the elements. So we know that classification is the grouping of elements or grouping of anything on the basis of their similarities and differences. So similarly, as we classify other things, we tried to classify elements also. And we made a periodic table. Periodic table is the arrangement of elements in the form of a table in which similar elements are grouped together and dissimilar ones are separated from one another. And making of a periodic table was a tough job because there are so many elements that had to be arranged in it. Out of 118 known elements, 92 occur naturally and are called as naturally occurring elements, and rest all are made by man, so we call them as synthetic elements. In 1808, John Dalton gave his famous theory, which is called as Dalton's atomic theory. And one of the postulates of this theory was that atoms of different elements have different atomic masses. So he said that atomic mass is the fundamental property of an element and it can be used to differentiate different elements from one another. So taking the clue from Dalton's atomic theory, the historical development of the periodic table started and the scientists tried to classify elements on the basis of their atomic masses. One of the earlier attempts was done by Johann Wolfgang Doberiener. So he arranged elements in a group of 3 in the increasing order of their atomic masses. And he said that if we add the atomic mass of the first and the third element and take out its average, then this average will be equal to the atomic mass of the middle element. So he made a few more triads like chlorine, bromine, iodine. On adding the atomic masses of chlorine and iodine, we get the average 81.25, which is approximately equal to the atomic mass of the middle element, which is bromine. Similarly, calcium, strontium, barium. On adding the mass and calculating the average of calcium and barium, which is 88.5, it is approximately equal to the atomic mass of the middle element, which is strontium. When Doberiener gave his triads, approximately 30 plus elements were known. But he could not arrange all the known elements in the form of triads. He could just give us a few triads. So his theory of triads was discarded and dismissed, considering it was just a coincidence. Next attempt was made by John Alexander Newland. He continued with the same concept of atomic masses and he arranged the elements according to their increasing atomic masses and he found a pattern. He found that the properties of every eighth element were same as the properties of the first one, and he related this discovery with the notes of the musical scale. He said that as there are 7 musical scales like sa, re, ga, ma, pa, dha, ni and then sa again. So he said that every eighth note of the music is same as the first one. Similarly, the properties of every eighth element is the same as the first one. For example, if hydrogen is the first element, then after that fluorine will be the eighth element. So these properties are same. If we consider lithium as the first element, then if we count lithium is the first, then second, third, fourth, fifth, sixth, 7th and 8th. Then sodium will be the 8th element and their properties will be same. If beryllium is the first, magnesium will be the 8th, properties will be the same. So he said that properties of every 8th element are same to its respective first element. And this law was called as Newlands law of octaves. So let's see it once again. This law states that when elements are arranged in horizontal rows in the order of their increasing atomic masses, the properties of every 8th element were similar to the first one, just like the 8th note of a musical scale. Newlands law of octaves was one of the finest works of its time, and it was appreciated a lot, but it had many limitations also. When he gave his law, there were 56 known elements, but his law could be applied only up till calcium. After that, it was not applicable for the heavier elements. When later on noble gases were discovered and he tried to fit in the noble gases in his table, then his octave thing could not be applied anymore, because that time the properties of every 8th element were no longer same as the first one. He anticipated that only 56 elements exist in nature and in future no discovery of elements will be done. And he did not leave any gaps or any spaces for the future discoveries, and this is also considered as one of his limitations. At places to fit in all the elements, he kept 2 elements in the same slot, and we know that this is not possible because 2 different elements cannot have same properties. Under the same note, he kept dissimilar elements. For example, hydrogen, fluorine, chlorine and this bromine. These are all non-metals, while cobalt and nickel, they are metals. So he kept metals under the same note as the non-metals. So this is another drawback. Also, he kept similar elements away from one another. For example, cobalt and nickel are same as iron. So they were kept under different notes. So all these are few drawbacks of Newlands law of octaves. So let's see quickly once again. His law is applicable only to the lighter elements up till the atomic mass 40, which is of calcium. After the discovery of noble gases, the properties of 8th element were no longer similar to the first one. He assumed only 56 elements existed and no new elements will be discovered later. To adjust all the elements, he kept 2 elements in the same slot. Unlike elements were put under the same note, as we have seen, he kept metals and non-metals together. Similar elements were kept in different places. For example, cobalt and nickel, which are same as iron, but they were kept in different places. To overcome the drawbacks of Newlands law of octaves, Mendeleev gave his periodic table. At that time, 63 elements were known. So he took 63 cards, wrote the name of all the elements on these cards along with their atomic weights, physical and the chemical properties. He found the chemical properties of all these elements by reacting them with hydrogen and oxygen and found the formula of their hydrides and oxides. Then he started pasting these cards on the wall according to the similar chemical properties, means the elements which had similar properties, which were showing similar formulas for hydrides and oxides, they were pasted one below the other, just like this. So he found that lithium, sodium, potassium, they were showing similar kind of compounds with hydrogen like LiH, NaH and KH. With oxygen, they were forming Li2O, Na2O and K2O. Similarly, beryllium, magnesium, calcium were forming BeO, MgO and CaO. And in the same manner, all those elements which were showing similar properties, they were pasted one below the other on the wall. At the end, he was thrilled to find that all the elements were automatically arranged according to their increasing atomic masses also. So the periodic table made by Dmitry Ivanovich Mendeleev was made on 2 bases. Number 1, in this elements are arranged in the horizontal rows on the basis of their increasing atomic masses. Number 2, on the basis of their similar chemical properties. Then he gave his law called as Mendeleev's periodic law. This law states that physical and chemical properties of elements are a periodic function of their atomic masses. Periodic function means properties of elements are repeated after certain regular intervals. And this repetition of properties of elements after certain regular intervals is called as periodicity of the properties. This is how Mendeleev arranged all the elements in his periodic table. He divided his table into 8 vertical columns and named them as groups. So from group 1 to group 8. He also made 6 horizontal rows to make 6 periods in his table. Group number 1 to group number 7 were subdivided into subgroups A and B, while group 8, it contained total of 9 elements which were placed in a set of 3. So each this set was placed in period number 4, 5 and 6. Later on, when noble gases were discovered, so he could simply add these noble gases by adding another group which he named as 0 group. So all the noble gases which were discovered later were placed in this 0 group. So these were the few characteristics. Let's see them once again. In the Mendeleev's periodic table, there were 9 vertical columns from 0 to 8. Except for 0 group and the 8th group, all groups were divided into subgroups A and B. 0 group contained inert gases. Group 8 contained 9 elements in 3 sets, each containing 3 elements, and there were total of 6 horizontal rows, which he called as periods or series. There were many achievements of this Mendeleev's periodic table. First and the foremost was that it systematized the study of elements, because in one group he kept all those elements which showed the similar chemical properties, so it became very easy to study the properties of elements. He also corrected doubtful atomic masses of certain elements. For example, beryllium, which was earlier assigned the atomic mass of 13.5. So while he was adjusting the elements according to their increasing atomic mass, so the position of beryllium should be between carbon with mass 12 and nitrogen with mass 14. But here at this place, properties of beryllium were not matching at this position. So he recalculated the mass of beryllium and found that its mass should be 9U. So it was wrongly calculated earlier. Now he fitted beryllium in between lithium and boron with masses 7 and 11, and he found that at this position, properties of beryllium were matching with the other elements. So he corrected the doubtful atomic masses of certain elements. He also predicted the discovery of new elements and left some gaps in his periodic table. And he did not see these gaps as defects, but he boldly predicted that in future certain new elements will be discovered and they can be kept as at these positions. He also gave pseudo names to these elements like Eka boron, Eka aluminium, Eka silicon, and later on actually certain elements were discovered which could be fitted at those empty places. So for Eka boron, scandium was discovered. For Eka aluminium, gallium was discovered. For Eka silicon, germanium was discovered. Position of noble gases. So when later on noble gases were discovered, he could place those noble gases by making or by adding another group called as 0 group without disturbing the rest of the periodic table. Do you know why noble gases were discovered so late? I hope you got the answer right. Noble gases are present in extremely low concentration in our atmosphere, and above that they are highly inert. They do not react with any other element because they are already stable. So it was difficult to discover them earlier. Despite so many achievements of Mendeleev's periodic table, it had many limitations also. The first limitation is anomalous or the controversial position of hydrogen. Hydrogen resembled two different groups of elements. It resembled alkali metals as well as halogens, and he could not justify where hydrogen should be placed. Next is the anomalous position of some elements. Now we know that in his periodic table he arranged elements according to their increasing order of their atomic masses. But in his table he placed certain elements in the reverse order. For example, argon, which has the mass 39.9, was placed before potassium, which had mass 39.1. So he placed an element with higher atomic mass before an element with the lower atomic mass. And there were similar pairs like aluminium and silicon, cobalt and nickel, tellurium and iodine. So he did not justify this also. Position of isotopes. We know that isotopes are the atoms of the same element and they have different atomic masses. Now because in his table he kept element with different atomic masses at different positions, he arranged the elements according to the atomic masses. So for that isotopes should get different positions. For example, there should be different position for carbon 12 and different position for carbon 14, but he did not do that and he even could not justify that. He also divided his table in subgroup A and subgroup B, and if we see closely, there is no resemblance in the properties of the elements present in these subgroup. So there was no point making these subgroups. He kept different groups for similar elements. For example, copper and mercury are similar, but they were kept in different groups. Like copper was in 1B and mercury was kept in 2B. Uncertainty in the prediction of new elements. Though he boldly predicted that many new elements will be discovered in future and he left a few gaps also. But he could not tell how many more elements can be predicted because atomic masses do not increase in the serial order. For example, if we see the atomic mass of lithium, it is 7, then it is 9, the next is 10, the next is 12. So there is no serial order in which atomic masses are increasing. And if we see the higher elements, for example, lanthanum, it has the atomic mass 138 and the next element has 178. So this is too big a gap and we do not know that between 138 and 178 how many more elements can be discovered. So there was uncertainty in the prediction of new elements. So all these were the limitations of the Mendeleev's periodic table. We will discuss the first limitation, that is anomalous position of hydrogen, in detail now. Hydrogen resembled two different groups of elements, that is alkali metals, which are lithium, sodium, potassium, rubidium and cesium, and it also resembled halogens, which are fluorine, chlorine, bromine and iodine. So we will discuss separately that how hydrogen resembles alkali metals and how it resembles halogens. We start with the alkali metals. And let's choose one alkali metal out of these. So we choose sodium. We will now see that how hydrogen resembles sodium. We know that hydrogen forms H positive ion, which is a monovalent positive ion. Monovalent means one valency. Similarly, sodium also forms monovalent positive ion, that is Na positive. Hydrogen reacts with halogens like chlorine to form HCl. Similarly, sodium also reacts to form NaCl, which is a similar kind of compound. Both react with oxygen to form similar compounds like H2O and Na2O, with sulfur H2S and Na2S. So we see that hydrogen resembles alkali metals because it forms similar kind of compounds with reaction with the similar elements. So to remember that we need to react hydrogen and sodium with these three things, that is chlorine, oxygen and sulfur. We will remember this acronym CLOS. So Cl, chlorine, O is oxygen and S is sulfur. CLOS, with this we will remember that we need to react hydrogen and sodium with these three elements. Now we will see how hydrogen resembles halogens. So again we will choose one of the halogens, which is chlorine. Compare now with the hydrogen and halogen. Both form monovalent negative ion, that is H negative and Cl negative. If we react both these elements with sodium, they form similar compound like NaH and NaCl, with calcium CaH2, CaCl2, with nitrogen NH3 and NCl3, and with carbon Both form similar compounds like CH4 and CCl4. So to compare between hydrogen and chlorine, we have to react them with the 4 different elements, which is Na, Cl, N and C. So you can remember these 4 elements. So now we see that hydrogen resembles alkali metals also, and hydrogen also resembles halogen. So the position of hydrogen was controversial and it could not be justified. This is our journey so far in the study of the periodic table. First of all, we studied about Dobereiner's triad. Taking the clue from Dobereiner's triad, Newlands also arranged the elements according to their increasing atomic masses and gave his law of octaves. To remove the flaws which were present in Newlands' law of octaves, Mendeleev gave his periodic table. Today we have learned that in Mendeleev's periodic table also there are many limitations, and these limitations were removed in the modern periodic table that we will be studying in the next video. Thank you.